So, in case you haven't seen my other climb series, okay, just in case, well, it's this. Now, the difference between what we're going to do today and the series I did in the past, well, they might seem the same systems, okay, but they are actually vastly different. So, in the first series, what we did is basically create a system based off climbing positions. So you have your positions, okay, you can place them around them over here, and your character was moving on a grid. On the climb system we're going to see today, which is of course inspired by Breath of the Wild. Now, it in parts is inspired by Breath of the Wild, but that climb system was actually not something new. Well, I was mostly more inspired by the Dragon's Dogma climb system, where you were able to climb actual monsters instead of just positions. But it's still the same. We're not going to see monsters, at least not yet, because it has to do with moving objects. And okay, as you can guess, there is a lot of stuff that you need to worry about if you're climbing system also needs to move. So I'm not going to show any footage from any Legends of Zelda games or from Breath of the Wild because you know Nintendo is a little bit picky. I hope you know what it is. I've also haven't played the game. I've only watched videos of how the climb system works, but it's just simply easy to understand, so it's not really a big deal. Okay, now back to the differences. As I said, okay, we have a few points on this position, and basically your character is moving either from point to point, well, not either, from point to point, and all these points store more information. For example, we later on later parts you will see that we also have hanging points, something like this, okay, and other stuff that you could do. So the idea for this, as I said, and as I have covered pretty much in all of these videos, as you can see, and I probably have forgotten to add a few of them in the list. As I can see, yeah, we're going from 9 to 13, so yeah, there's more than just these animations, just these videos. Okay, and yeah, so the difference between the system we're going to see today, it's, well, of course, it's not done yet, so I'm going to break it into smaller chunks so that it's easier to digest instead of learning a whole new system the same way I did with the previous climb system. Well, yeah, this is going to be very much easier to understand if we're going it step by step. So for right now, there is no IK, there's no animations. We're only going to focus on the logic that will make us climb all of this. And in this one, the vast difference is that this guy is white and the other guy was green. Okay, that's the vast difference. Of course, I'm kidding. There is many more differences. So the differences is that this doesn't need any more points. Okay, I haven't placed anything. I can move through all of these edges, and not only we can move, which we will also adapt to the rotation. Okay, for example, like this, and in any rotations. And right now we're just going to leave it as it is, like climbing or not be able to climb, but after a few parts we're also going to make him, you know, check the angle. So if the angle is let's just say something like this, then that means you can climb up. Okay, and then move on. Now this system actually is working on top of a third-person controller. You can use any controller you want. It doesn't matter. We're not going to focus or see anything that has to do with a third-person controller. This is taken from the advanced third-person controller. If you have another controller, we're pretty much the same idea as the previous climb system. We are closing one controller and we are enabling a new controller. So let's see this guy work. And all we're going to see, you might see him jump a little bit. Okay, we are on the wall, and based on my input I can basically move around. Now I can move freely. There's no arcade, there's no animations, there's nothing at this point. Okay, so what we want to see is how we can actually also adapt on the environment, which is probably going to be the most easy part we're going to see in the system, and because restricting the whole movement and adding the arcade is going to be a whole different set of issues we have to resolve. Okay, and of course if I go up, we'll see this. And if we look up pretty close, let's focus on him. Notice there is a little white line over here, as you can see. Let me bring my game area on the other way. Okay, this tells us basically where we are moving, and for right now it only serves as a direction placer so that you know where you're trying to climb. There is no, or if there is a wall or if there isn't a wall. So for right now it's only going to do this. Later on we'll see what I'm going to do with it. You'll see some nice stuff, but for right now, as I said, we're going to break it down into really small chunks so that it's easier to digest. And we're going to create a new script entirely. We're going to just call it free climb. Okay, it's going to go onto our controller and it's basically these three values. For the animator, we're only going to have, well, one animation. You can get it from my previous climb system video. We're only going to work with this, and later on this one and the mirrored version of this, which is going to be this. And if you move it pretty fast, okay, he looks like he's dancing. So let's go. Just drop something over here, doesn't matter. We're going to crossfade, we're not going to use any transitions, nothing. We're going to handle everything through the script. Here's our controller. As I said, use any controller you want, it won't really matter. Let's open the free climb and jump up. The connection between the controller we have right now or any controller you want to have, we're going to just use our state manager. Okay, in my controllers I always have state manager, and I always use an input handler that is going to go and update stuff or update variables as the state manager. So if you need to change the inputs, you're only changing the input handler. If you need to change something on the states, you're changing the state manager while leaving the inputs alone. Okay. So this is basically what's going to do the connection between this climb system and the other climb system. And what I've done with this in my state manager, which is over here, I've added a new boolean. Okay, it's climbing. This is entirely the advanced third-person controller on the final video, but as I said, it doesn't matter. It will work with any other controller you might want to have. So of course I've added also a reference to this, to our free climb, and we are initializing this and we are passing the climb basically. And I'm pretty sure that I didn't actually add anything else in the state manager, and yeah, I did. Okay, that is enough with the third-person controller. Well, actually that's not enough. We also need to see one more thing. Oops, not pre-climb. I wanted the state manager, and this is the state manager. And inside our fixed tick, if you have your regular update, you can use the regular update, but I'm just going to use the regular tick. Well, basically only the fixed tick is what matters. If it's climbing, okay, run the update from the climb behavior and don't do anything else. Otherwise, go back. And if you're not climbing, I'm just going to make it the same way like Zelda. If you are running forward, if you're walking forward, there's a wall. Check if you can climb the wall. Okay, and if you can climb it, of course, climb it. That's pretty much the only additions to this. And I've only added one more thing, so I lied, I guess, which is over here. That says if you are climbing, then okay, return, don't do any ground checks, because this overrides the position of your player and places him where there is the ground. Okay, now of course, depending on the controller you are having or you are using, you might not need to do any of this or completely disable it. It will have worked both. The reason why I'm not well, technically I'm not disabling it, but any calls that I have on my fixed update and my regular update, okay, they are not running any behaviors, because on the first line they simply return the empty void. Okay, but I want to keep my state manager because I want to use my horizontal or vertical inputs basically. And for me, it just makes sense that there is a script that controls what you're doing rather than throwing out the events anywhere. Okay, so be aware of that. So check for climb. As you can see, it couldn't be any more simpler than this. You have your origin, which is your transfer position. We're going to add a bit more on the upwards. Okay, this is the transfer position. We're going to check around over here if we can climb something. Otherwise, you'll just be, if you hit something too small, well, your character might try and climb that, so that's probably not what you want to do. Direction, of course, will be transfer forward. We're just doing a rate cast, and if we hit something, we are initting with a climb. Keep in mind we have also the ignore layers, so there's no chance we're going to hit something of our player, either a ragdoll or his own glider. And to initialize for the climb system, we say on our state manager that you're climbing. We turn our rigid body to kinematic, so we don't want any forces to apply to our character, which kind of simplifies a lot of the stuff. We might change this later or in the future, yeah, depending on what we're going to do. But I think even with this as kinematic, you're not going to find any problems. Now, the first thing that we're going to focus on, or well, we're going to find, is that when we hit a position on a wall, okay, we need to actually go somewhere, and we can't just play the animation, well, make him play the climb animation just like that. Okay, that wouldn't really be make much sense. So the initial position we're going to tell him where to go will be simply where the hit point is. So the first thing we're going to do is going to do a simple lerp from this position to the hit point. I don't know if this is the actual position we are going to get, but this is the point. Now ignore the other stuff. Most of the stuff comes from my other third person, for my third person controller, so we don't really care about any of this. Okay, and yeah, so of course we need to know if we are actually in position or not. So the first thing we're going to do is in position will be false. Now this is a helper transform that it's actually going to help us orient ourselves on, well, this, on the wall. And on the initialization phase, you can see that we are creating a new game object and we are assigning the transform, and we're just going to rename it to climb helper. So this helper object will basically find, or well, it's basically a way to store the position of the wall. So when you're hitting with a raycast, you can get hit.normal, and it's going to give you the normal direction of well, your collide, or where your hit. Okay, so that means with this we know where the actual that the wall we hit looks over there. So if we get the opposite of that, that means we have the rotation that looks towards the wall, so that means we also know where we want to rotate our character. And this, before we actually rotate our character though, we're going to just place a helper immediately over there. Okay, so the rotation we want is look rotation, the opposite of our normal. The starting position is going to be our own position, and the target position will be our hit point plus a little bit of an offset from the wall. How we apply the offset from the wall? We're basically just taking the hit normal, the correct one, not the opposite. Okay, and we multiply it by an offset from wall. This is heavily depending on the animation you are going to use. So in my case, I'm just going to use 0.3 offset. Okay, and we're basically placing your character a little bit further back. And I'm just going to do a crossfade to the climb idle with this. If we want to use later other animations, stuff like that, we can do it. We can simply crossfade to that animation, but for right now, there's no need to mess with any transitions, there's no need to mess with anything else. We can simply do it like this. And we're also going to reset the T. So with this, because we've turned state is climbing to true, that means on our state manager fixed tick, it's going to see that it's climbing, and it's going to run the update for the climb instead of the state manager. Okay, on our first time we're going to get into the update, it's going to check that if you are in position or not. If you are not in position, it's going to run the logic to get you into the correct position, otherwise it's just going to return. So to get into position, you can see it's just a simple lerp. The speed is this. If T is higher than 1, then that means you are in position, otherwise just continue with the lerp and place you over there. So we are in position, that means we have to move. And here's what we're doing basically with our movements. We want horizontal or vertical values. Okay, this is the raw input from our character, from the player, basically what the player is pressing. In this instance, up of course will be climbing up, down will be climbing down, left and right you can guess what it is. And we want to use a float M. We're basically just is a way to have movement, so we multiply that with a speed multiplier. Okay, it's basically just a simple way to do this. We're using the absolute value of both of them, because if you are pressing diagonally movement, so for example if you are pressing up and left, that means left is going to be -1 while up is going to be 1, then that means you are getting 0, so that means there's no movement. Okay, of course that's not something we want, so we are adding with absolute values. And then we can create basically our vector directions where we want to move. And here's where the helper is going to play, because our transform position is going to be a little bit or our transform rotation is going to be a little bit variable. Okay, we need a helper that stores the position, and we're moving relative to where the helper is looking and not where the player is looking. But for the most cases you can see that we're actually rotating our player. Okay, but we cannot get the player's rotation, because if the player is currently rotated half point to this, okay, so he's trying to get the rotation, as you can guess, then you'll have problems with the direction. So for example, if oops, let's get out of here. So for example, let's go find something more extreme, something like this. Okay, your player wants to oops, to move towards here, but he also rotating, but he hasn't yet rotated, so that means on the percentage you are rotating, you are not yet onto 1, which will mean you have this rotation, and maybe you are over here. Okay, the upward of this rotation will be here, while the only while the direction we want to move will be over here. So the helper, what it does is basically adapting, is what adapts to the surface. So the helper is not going to do any spherical lerp, it's just going to tell you that it's rotated like this or it's rotated like this. So you can freely move like this and rotate at the same time. Okay, a simple solution into, well, not that complicated problem. Okay, so we get the helper right and we multiply it by horizontal. If of course it's negative, means we're moving left, so it's going to also turn this to negative. And the movement direction will be combined of this. Okay, of course we also want it to be normalized. Then we're going to do a check if you can move there or not, and if you cannot move, then simply don't do anything. If you can move though, here's your target direction. That will be the helper's position. The can move is basically what also places the helper. Okay, minus our own transform position. So that means we're basically just placing the helper on an offset around us. Okay, how on the first one we had different points over here, over here, over here, and we were moving between them. Basically in this one we're saying we are here, place a point over here and move towards there. And probably I shouldn't draw trajectory lines from between his legs, but anyway. Okay, so we're basically just placing a point well, the helper in a position next to us, and that's one crooked circle, and we're moving into that direction. And for right now we're moving really freely on that direction. Later on, where we have to worry about a case, you'll see that this is going to change. So target direction, transfer position plus our target direction, the movement, if we are actually moving or not. It's simply a yes or no, well, not a yes or no, it's a variable. So if you are, well, it's going to play a little bit different speed if you are using a controller, but well, in this case it's just a simple way to say you are moving or not. Okay, otherwise you can just check if any of this is not 0, then you are actually moving. But this is going to be multiplied with a speed multiplier. You can see that the value is very small because we only want to move a little small amount each frame. Okay, if you raise this even to 0.1, you will see that you start flying away. So it doesn't matter, we still just want to work with this. And the next thing we need to do is rotate from our current rotation to the helper's rotation, and by speed just make it fast in this case. Now this is the tick, so the only thing that we need to also see is can move with passing the move direction, which was over here. Okay, the move direction where you want to move. And what we're going to do right now, we have the origin will be our own transfer position, the distance that you're going to look for. So this basically controls the how far away you're looking. You can of course set this up as Okay, how far it's looking. You can set it as a public variable and set it from the inspector, but anyway, point 2 I think it's going to work well at this for this example. Okay, so basically we're going to do a recast like this to see that there is no other wall that blocks our way, and then we're going to do a recast forward and see that if there is a wall then you can move. If there is no wall, just stop. And to do that we are over here again, move direction, the debug draw array that you just saw. You have your distance over here, you can also place this over here. This checks if there is a wall towards the direction you want to move, just so that you're not, well, you know, a wall that is at 90 degrees angle, sort of like that. And if it's false, well, actually this could be double the speed, although maybe we should just do 0.4, or well, let's just leave it at 0.2 or the same, and we'll see if we need to change it. We're going to change it in the future. Otherwise, do another recast, just use the same variables. The origin is going to, we're going to add into our own transfer position, move direction plus the distance, so that means you are doing the recast with an offset from your own transfer position. And now of course it rebakes, it has to recompile everything, that's why that played. And we were over here. Okay, the direction we want to go is helper forward. For the distance of 0.5, we don't want to be really precise with this, we want to overshoot it. It doesn't hurt if we overshoot it. We want to do that because if you take this and rotate it like this, or let's just make it a little bit more extreme. Okay, you still want to hit it. If it was even more rotated, then it will have stacked, or we will have problems like this. Like for example, if you manage to hit to just fall on a very thin line over here that there's no collider, you might be it might stop you dead on your tracks. Okay, and of course there is also the case that we have to take care with over here, that when you are going upwards you also need to worry about the whole length of your character. And also, before I forget, yeah, there is a reason why Zelda is so short, or I believe, because it's going to make animations more tight. So this climb system might work a little bit better with a cartoon character rather than a realistic one, or at least a full height one. Okay, and yeah, so basically the next thing we're doing, we're doing a recast, we're doing help position with offset. All it does is you're passing an origin and you're passing the target. It basically just does from origin, subtracts from the target. Okay, it normalizes. You have your direction. You multiply with the offset from the wall, which is this 0.3, because I used on the animations I used. Okay, and returns, assigns the return value, and then returns it. Or you could have just do this, I guess, but force of habit. Okay, and returns you the target plus the offset. So that's where it's going to place the helper, and it's going to also clamp, or well, not clamp, make him rotate immediately towards the minus hit dot normal. Now you're going to think that minus hit dot normal is a direction, so you might be reluctant to use Euler angles and do this, but this is not going to give you Euler angles. Okay, directions are not Euler angles, and this is just going to hardcode 001 or whatever your hit normal is. Okay, And that's the basis of it, or yeah, well, really the basics of how you can also adapt on surfaces. And yeah, on the future we're going to also see a lot more stuff. For example, uh, let's just speculate on how I'm going to do this. For example, if you are on an edge case like this, where you are hitting upwards, like this, you can see that there's no wall over here. Yeah. Okay, there's no wall over here, so we can check downwards. So let's do this. Let's do this now. We have our can move, and we're going to say on our origin, add the direction again, multiply by the distance to 2. So this will give us the origin direction towards on the corner basically. And what we can do right now, the direction we want to look forward will be minus vector 3 up. Let's just do debug.draw array. Okay. Well, the distance, let's just keep it at 1 and we'll see. It shouldn't really matter. And we can say if physics breakcast origin dir out hit distance 2 stage dot ignore layers. Okay, so if you hit right now something, it's probably best if you want to encapsulate it, but we're going to see that on a later video. And well, we hit something. Now we need to also see, let's just do an angle check. So for example, let's check the angle. For example, let's say the angle towards our helper forward with our hit normal. And yeah, this might actually not be a good idea, because the helper forward, instead of forward, let's just do the upward, because it's just going to give you with a more well, the value you can actually use, because your player might look, or most likely look the opposite way of your forward. We can say that if the angle is let's just say 40. Okay, copy paste all the others. Otherwise, well, actually we don't need to write it, it can go by itself. Let's leave it at that, or let's just add another debug log just to see the angle. Let's rotate this, or let's make it like this. This will be 40. Maybe let's make it like this, doesn't matter. Okay, I can set it up anyway. I won't, shouldn't really matter. Let's see if this is going to work. Okay, I'm going to walk towards there. There's a few. We're going up. You can see that we adapt to the terrain. And you can see that it's broken over here because it hit an angle that he cannot really judge, or basically because the helper actually hit something over here. So the helper is probably somewhere over here, so his up vector is probably a little bit messed up. You see? Okay, because it hit this this side of the wall, is basically rotated to look towards there. But if we take this and place it back towards the correct direction, you can see that I have my control back to it, and we can move around. Okay, of course this will be edge cases we're going to take care of in the future, when we actually have to worry about also the arcade and even more stuff. And if I keep moving towards the right, you will see that because I don't do any angle checks on the other ones, it means that I can freely move towards all these other positions. Okay, the idea behind it is vastly different than, and that's basically another issue, that it's vastly different than all the other things, or well, the other climb system we did. But you will see that that doesn't make it not interesting. Okay, so for the first part, this is it, and on the next one we're going to just focus well, polishing all the stuff. Now the first part, the next part is probably going to be in about a week. This is of course for the patrons that are getting the early view. Okay, if you are watching this live on YouTube, then that means it's definitely going to be on the next week. Okay, and yeah, as I said, probably the next week, unless I don't, yeah, I have to work, which might get delayed a little bit. But yeah, well, that's all I have to say. Like, subscribe, share it, help the channel grow. Okay, if you like, support me so that I can continue making all of these things. And I just realized that I wasn't showing my games in. Okay, and as I said, if you like to support me so I can keep making all the stuff, then you can do so either on Patreon, where you also get to see the videos early, and you also, depending on the tier you are in, you'll also be able to see to some additional rewards basically. And the other way you can support me is of course via Gumroad, where you can get projects and which will also help you on both your own game. They go towards making more stuff, and yeah, that's basically how I keep this channel up. Now, this project is actually going to go along with the other climb system, so it's going to be the two climb systems together. It's not going to be a package, two separate packages, so that means if somebody has already the climb system, you're also going to be able to have both of them without paying anything extra. Okay, I don't do stuff like that. This is the climb systems, you can have them and have fun with them. Okay, if you also get it before this is done, you also enjoy in a little bit cheaper. Okay, I'm just going to raise it, the price $5 more. Okay, nothing extraordinary. I always want to have everything to be really approachable, so that anyone can actually follow them without having to worry or spending, you know, half a month's wage on a single project. Okay, I don't do stuff like that. So that's it, and I'll see you on the next one.